Example 2 for lesson 17 is a polynomial model. So we have this very complicated quartic equation that you see in front of us. And what this equation models is, in Canada, the hundreds of thousands of cubic meters of wood that are harvested each year. X is the time in years, and we're looking at X between 0 and 4 because we're specifically interested in the volume harvested in cubic meters between 1993 to 1997, so in that 4-year span. So we want to know in which years was less than 185,000 meters cubed harvested. So we've dealt with inequalities before, so you might be thinking, well, I can put in 185,000 for f at x. And I can subtract 185,000 from both sides. So that I have a 0 on the other side of the equation. So the constant term just becomes subtract 8,392. So really these two questions are equivalent in terms of finding out when it is 185,000, or you can subtract 185,000 from both sides and you can figure out where is this new equation when you change the constant equal to 0, when it's 0. But we're actually asked not for when it equals 0, but when it's less than. So I really should change this to less. When is this? Oh, other way around. When is this less than 185,000? So we want 185,000 to be larger on that side. I could write it the other way around, might be easier as well, but I've already got it set up that way. So when is this modified equation, when I've subtracted 185,000 from both sides, when is it less than 0? Okay, so thinking about that question, what I can do is I can try and find some factors and I can figure out if it factors and use polynomial long division. I don't think this one is going to factor nicely. I think the only solution is to use technology for this one. So we're going to pop over to Desmos and we're going to take a look at both of these kind of solution types. So the first way to do it is just to simply graph the polynomials given, so f at x, and this is still leaving the constant the same as in the question, so 176,608. And here's the picture that I have. You can see that I did have to go in my window and sort of modify what I can see along the x. So I really only need to see between like maybe negative 0.5 so that I can see the 0 clearly, and 5 because I only need to know between 0 and 4 what's happening in terms of the time in years. And the volume is going to be quite large. So I've started that at maybe, I don't know, negative 10,000 just so I can clearly see the x-axis. And I want to go up fairly high, so maybe 600,000, just to make sure that I can see clearly that curve. Okay, so it's kind of just a piece that we're looking at right now. You can zoom out to see a little bit more detail, but we're just interested between 0 and 4 years. So you will have to set your window there first. Okay, and we can also just draw a straight line. If you type in y equals 185,000, we'll get a straight blue line here. And we want to know where is it less than 185,000 in those 4 years. So let's zoom in just a little bit more here. And then I will be able to actually click on the points of intersection. So it's less than, that red curve is less than the blue line until it looks like about 1.2. So I'll just flip back over here. So when x is less than 1.2 years, and then it goes above until this point here. So when x is between 2.8 and 3.8, it dips down below again. So between 2.8 and 3.8. And then it's above again through year 4. Okay, so because it's sort of 1.2 years and 2.8 years and 3.8 years, you wouldn't have been able to factor this one. You're just going to use technology to solve this type of problem. The other alternative way to solve it in Desmos would be to, again, subtract that 185,000 from both sides so that it's just 0. And then we're just looking for when is this curve, the green curve, which you can tell is exactly the same as the red curve. It's just been shifted down 185,000. When is it negative? When is it below the x-axis? So that's the alternate way to solve it, is just to take a look at the green graph. So we can get rid of the red and the blue for right now and zoom in a little bit here, and hopefully we'll get the same answers. So it's up until 1.2. Again, it's below the x-axis, so when x is less than 1.2, and when x is between 2.8 and 3.8. So you get the same answer either way.